Hi, so I've got two more examples to go through here on slide 17 and slide 19, two sort of classic kind of things that you might be asked to do. So in this one here, we need to find the value of k, given a polynomial expression. So we basically need to find the coefficient of x squared, really. And the key thing is we're told that it's divisible by x plus 3. Now, you could do this by using reverse box method, but the factor theorem is so much more easier to use when you've got this kind of information. So we know that p of minus 3, we have to reverse the sign, x plus 3 becomes minus 3 is equal to 0 by the factor theorem. So that means that minus 3 cubed minus k plus 1 minus 3 squared minus 3 plus 30 must equal 0. Now this is good news. We've got an equation with just one unknown in it, so we should be able to solve it if it's solvable at all. Minus 3 cubed is 27, 3 3s are 9, 3s are 27, so it's minus 27 because it's an odd power. Minus 3 squared is positive 9, so it's minus 9 outside of k plus 1. Not trying to do too much at once. Minus 3 is plus 3 plus 30 is equal to 0. So just looking at the whole numbers there, I've got 30, 33, take away 27, so I'm left with 6 if I'm not mistaken. So I've got 6, and I'm just going to expand that. 9k minus 9 is equal to 0. Look at me putting my equal signs underneath each other. That's a good thing to do. Okay, keep on simplifying. I've got minus 9k is equal to, so minus 9k, 6 minus 9 is negative 3, is equal to 0. Minus 9k is equal to positive 3, and k is equal to negative 3 over 9, or negative 1/3. So that would be the value of k. Done, done, done. Example 2. Factorize x cubed plus 8x squared plus x minus 42. So we have no particular technique that we can use to factorize this. Is there a common factor? No, there isn't a common factor. It's a cubic, which means we don't really have too much of an option except to try and find factors. And that's where the factor theorem becomes really handy, because what we can start doing is we can just start throwing in values for x until we find something that sets that polynomial equal to 0. Now, what numbers should we try? Well, you start off with the smallest because they're the easiest to do, and you build your way up. But you don't have to try every single number under the sun. In fact, if you think about it, that minus 42 is going to be really critical. So it's factors of 42 that are going to be the ones that you can substitute in. The reason why is because we're going to eventually have 3 sets of brackets here if it can be fully factorized, and it's this times this times this, which is going to give you minus 42, right? So just looking at factors of 42 will eventually get you a factor if it exists. So keep that in mind. You don't have to go through every single number. There's no point trying 5 and negative 5. But we should be systematic about it. 1 goes into 42 or minus 42. So typically we start off with p of minus 1, and I substitute that in. And all you're trying to do really is trying to figure out whether that's going to give you a 0. If it's obvious that that doesn't, you can move on. So I'm going to have minus 1 plus 8, that's not going to be equal to 0. I like putting this in, therefore x plus 1, not a factor. Some people don't bother with that because they can't be bothered writing it all out, but I think it's worth it. Do the same thing with p of 1, although I'm pretty sure that this is not going to work either. Looking at the numbers there, I'm just not going to get anywhere near 42, so I'm not finding it, and therefore x minus 1 is not a factor. Okay, let's try p of 2, or p of minus 2 first. This is where it gets a bit better. Minus 2 cubed is negative 8, plus 8 times minus 2 squared, it's 32. Now we're getting somewhere, I think. Might not get us where we're looking for, but it's certainly worth looking at. So I might do it under 2 lines here to make sure. Minus 2 cubed is 8, so it's going to be minus 8. Minus 2 squared is positive 4. 8 4s are 32. Minus 2 minus 42. So that's, let me see now, 32 minus 2 is 30 minus 8. 30 minus, that's not going to get me 42 anyway. So that's not a factor. So x plus 2 is not a factor. Let's try p of 2. I feel like we're getting closer though. 2 cubed plus 8 times 2 squared plus 2 minus 42. What does that give us? 8 plus 30, 8 fours are 32 plus 2 is, oh, hang on, here we go. 32 plus 8 is 40, plus 2 is 42, minus 42, hooray, equals 0. Therefore, x minus 2 is a factor. Great. Now, technically, we could then keep going with p of minus, well, don't need to, yeah, minus 3. So p of minus 3, p of positive 3. There's no point trying 4, no point trying 5, p of minus 6. But we could keep doing that until we find all the factors, assuming they exist. But we don't know whether it's factorizable at all. And we don't know whether it's going to factor into 3 linear expressions, or whether it's going to be a linear expression, i.e. degree 1 multiplied by degree 2, that kind of thing. So technically, usually we just find the 1. Once we've got the 1 factor, then we use something like the reverse box method to continue. So it's a polynomial of degree 3, which means I need 3 boxes or 3 columns in the 2 boxes, and I know that x minus 2 is the factor I'm looking for, so I can put that, and away we go through the process. The leading term gets put here, x cubed, which means this has to be x squared because x times x squared is x cubed. What am I looking for in this first diagonal? I'm looking for 8x squared, and the next diagonal I'm looking for is x. Okay, just putting that there so I've got it. X squared times minus 2 is minus 2x squared. I'm looking for 8x squared, so I'm going to have to put 10x squared in here to compensate. Awesome, awesome, awesome. What do I need here? X times what equals 10x squared? Well, positive 10x. 10x times minus 2 is minus 20x. Okay, keep going. I'm looking for minus 20 plus what will give me x, and I'm going to have a 21x, aren't I? So positive 21x here. Big numbers, but we can do it. X times what will give me 21? Well, it's plus 21 here. We've got 21 times minus 2 is minus 42. Do a quick check, and yep, sure enough, this minus 42 is the same as this minus 42 here. So I have factorized properly. Always worth doing that really quick check. Okay, cool. So we've got x cubed plus 8x squared plus x minus 42 is equal to x minus 2, the factor I found by the factor theorem, and x squared plus 10x plus 21 as my second factor. Now that I've got as a trinomial, I can use any old method I wanted to try and factorize that. Whether I can do it by inspection, they call it, just by looking at the numbers and seeing if I can figure it out, or by using box method here, or some other sort of method, we can go for it. But I can see by inspection what it's going to be, probably because I work at the problem myself. So 7 times 3 is 21, and 7 plus 3 is 10. So now I can factorize it fully to x plus 7 times x plus 3, and now it is fully factorized.